Let's proceed now to the next number. In a simple pendulum, a student measures the period t of the pendulum many times and obtains an average value, which is 2.540 plus or minus 0.005 seconds. The length of the pendulum is measured to be the length, which is 1.60 plus or minus 0.01 meters. Calculate using g, which is equal to 4 pi squared L over t squared, the value of the acceleration of freefall, including its uncertainty. State the value of the uncertainty to one significant figure. Of course, getting the value of g with calculator is very easy, so all you need to do is just to substitute it. So you have g is equal to 4 pi squared times 1.6 all over 2.54 squared. And of course, the answer there is 9.79 meters per second squared. So, how will we get the uncertainty here? We can use this, my formula here, or you can actually use the percentage uncertainty. Remember that you're getting g, the uncertainty of g, and you have L over t squared. You don't really care about the 4 pi squared because they are constant and they don't have uncertainties. So I will just do delta g all over 9.79 is equal to 0.01 over 1.60 plus 2 y2, because you need to multiply it by 2 because this is t squared, times 0.005 all over 2.50. So the answer here is equal to 0.1 meters per second squared. Notice that I just got one significant figure because of the condition that was given for the question. And at the same time, I got three significant figures for the answer because there's 1.60 here, and there's three significant figures for the answer here, referring to the given. Okay. Next, in a different experiment, a student investigates the dependence of the period t of a simple pendulum on the amplitude of oscillations theta. The graph shows the variation of t over t sub 0 with theta, where t sub 0 is the period for the small amplitude oscillation. So you can see here that this is the theta and this is t over t sub 0. The period may be considered to be independent of the amplitude theta as long as t minus t sub 0 over t sub 0 is less than 0.01. So this is the condition. Again, this is the condition. Determine the maximum value of theta for which the period is independent of the amplitude. Again, it's independent of the amplitude. So you can see here, where will be the maximum value of theta? So what I will do is t minus t sub 0 over t sub 0 less than 0 minus less than 0.01. So what I will do is I will factor it out and I will get 1 here, transpose it here, and I will get t over t sub 0 less than 1.01. So in the graph, I can see here that this is 1.01 and this is roughly equal to 22 degrees. So this one, the maximum theta is given to be 22 degrees. So this is for the second number.